So we have to look at ways to control disease without fungicides. And what we use is, as a plant pathologist, people always put up the disease triangle. Presumably you're familiar with the disease triangle, where you have disease, but I use the pyramid of disease. I saw this first in a Indiana Jones film, the Pyramid of Disease. It's very good. So we have the pyramid of disease where there's 4 factors interacting to affect the level of disease here. And what we as turf managers have to do is look at ways to influence these factors so that we can reduce the level of disease. Now, I'm not going to spend much time. This segment here I could do maybe 4 hours on, but don't panic. So I'll go through it very quick. I'm going to look at things like cultural controls that will control disease, and defense activators, crossed out that for here, and nutritional inputs, which we all use, and how they have added benefits of not supplying nutrients, but as I tried to explain to Michael Woods there a few weeks back, they're applied with added benefits because they have direct effects on plant health and stimulating defense mechanisms. So, and just go back to the pyramid of disease here. We have to influence these factors here. Now, the pathogen, no matter what disease you dealt with in the past, be it anthracnose, mycodocium, the source of that disease, the inoculum, is going to be there in your soil, in the attached layer in the environment. And what I will say, though, is get to know your enemy. Now, you probably only deal with a couple of diseases through the year. So understand what they like, what environmental conditions suits them, what grass species or cultivars they like to attack, and see what you can do in that area. So when we talk about the environment, how we can influence it, not just the climate or the weather, because you can't do much about that. Talk about the growth environment, what we do on a day-to-day basis, cultural management, and there's quite a few things here that you can tweak to affect disease levels. And what we're looking at bit by bit, on their own, they probably won't have much effect. They have a little bit of effect, but they're basically like a jigsaw. When we start putting them all together, you get the full picture then. So one thing that has a significant effect on disease levels is leaf wetness duration, right? How long your leaf is wet in the mornings or through the day. And if you're anything like us, I think you are at home, you can, especially this time of the year, you can get long periods of dewy weather, yeah? Good, people are nodding, that's good. And not only dew, of course, there's glutation fluid, which is exuded from the plant, which is full of sugars, bit like a McDonald's for fungi, really. So dew removal is a crucial factor in helping to reduce disease pressures. And there's some published data on it. Dollar spot, mycodocium, brown patch, and anthracnose. So they've shown that the duration of leaf wetness, say it's over 24 hours of leaf wetness, ideal for the fungi to germinate and grow and infect. And so if you can dry your leaf off, either physically, anyone use switches or brushes to dry it off, that's important. A lot of people in the UK are doing this continuously. Or do you have dew suppressants here, Dave? No?
We're trying to look at.
Okay. A lot of people use these. These are a type of surfactant that people apply, especially through the fall. I speak Canadian. They apply it from the fall right through to spring, this time of the year. Surfactant, they apply it and it reduces the level of dew. And this is from ICL in the UK, done at the STRI, the Sports Turf Research Institute. Is looking at this dew suppressant. They suppressed dew and they looked at mycodocium infection. The untreated blue there. So you can see where they suppressed dew, they got less disease. Not full control, but they reduced the level of disease. So dew control is very important. And again, if you're using these dew suppressants, just remember, not all products are the same. This was done by Cale Bigelow down in wherever it was, Purdue in Indiana. All that stuff was applied at the same time, so you can see the different results there. So remember the catchphrase. No matter who comes into you, ask them, show me the data. And any good company will have solid scientific data to support their products. Is that right, Dave?
Absolutely.
So show me the data is important. Now on the same area of what we're talking about here is, I always tell the guys, a good way to control disease is using a chainsaw. Yeah. Okay? Reduce the level difference. Open up the canopies. Why? Because you're getting better air movement in. You can help dry the plants off. But you're getting better light, especially through the fall and winter and autumn. So more light means more photosynthesis. The plant can produce more compounds for defense. It can help support more carbohydrates, have it in store. So vital in the autumn, winter, but also through the summer as well. Height of cut is important as well. How so? Well, again, you're increasing the height of cut even slightly, increasing leaf area, better able to produce compounds for defense and respond to stresses as well. So mowing heights can help a lot. And in fact, here's some work done in Rutgers University down in the States. I've never been able to see it down in the States before. It's always over in the States. So down in the States at Rutgers in New Jersey, this is the effect they looked at, mowing heights on anthracnose. Increased it from 2.8 mil to 3.6. Do the conversion yourselves to hundreds of whatever it is, inches. But increasing it slightly reduced anthracnose. So that's 2.8 mil, 3.6. It's okay, as I'd say. Okay, well, what about maybe my green speed is going to reduce? But you can see the differences there in the height of cut. So this is where rolling comes in as well. I'm glad that slide came up in time. So increasing height of cut, increased regular rolling. It's going to do a few things. It's going to, if you're not early, you're removing dew, so leaf wetness, that's be cured. You're maintaining playing quality. And regular rolling, and this is more data here from solid research, regular rolling will reduce disease. This is Clint Mattox, down south in Oregon State. I've never said that before either. Anyone know Clint Mattox or his work? That's good, yeah, because a lot of people, I asked this in the UK and they haven't heard of him. But he's done a lot of work looking at controlling disease. So down south in Oregon, he did a lot of work with rolling, and you can see it here. So the black, this is microdocium levels. Black, not rolled. That one rolled 5 times a week. So it's reducing disease just by rolling there. Now again, it's an interesting chart. Applying sulfur reduced disease. Applying calcium phosphate reduced. But this is what we're talking about here. This combination of sulfur, other products like phosphate and rolling. So combining all these things are working in different ways and reducing disease. This is from Denmark, actually, Copenhagen, where they have no chemical controls whatsoever, really. The Royal Copenhagen Golf Club. Just by rolling, you can see the difference here. Regular rolling is going to help big time. Dollar spot is the same. Sorry, that's anthracnose there. So we saw where height of cut affected anthracnose. Rutgers is showing rolling here, regular rolling, without rolling, compared to that, will reduce it also. It also reduces dollar spot. Okay, this was done by Paul Giordano. I think he used to be up in Toronto. I'm not sure where he is now, but not rolled here. But you can see just by rolling. Now, this was, they already had removed the dew, so it's not a dew effect here. This is just from rolling. Now, at this stage, people usually ask a question. What is the question? How does rolling affect disease levels? Anyone, any ideas? No? I was hoping you might tell me.
Breaks the exoskeleton of the disease.
Well, breaks the exoskeleton of the disease. I never thought of that. I have to think about it. Could be. Now, what I'm going to say is there's no definitive answer, but that's an interesting thing to follow up on, actually. But there's a few possibilities. Rolling does reduce disease. One way, what I think, is that it's causing a slight stress to the plant and stimulating the defense responses. When plants are being infected, they will respond with some very complex biochemical defenses. So rolling could stimulate them and help to ward off the disease. Sometimes then, if you are rolling and there's a dew there, that's going to have an effect also. But there's also a change that's been shown in the microbial community. And let me just put, hello? Oops, that's good. Yeah, so it's been shown that the changes in the upper levels of volumetric water content following rolling. Now, it's not going to cause excessively wet surfaces. But you can see here from this work done, I'm not sure where it was done actually, but there's a slight increase in the volume of water. And if we get to it later, I'm going to show where surfactants, actually I think I mentioned it this morning somewhere, surfactants are increasing the wettability of this upper root zone, and there's an increase in microbial activity and enzymatic activity, and basically an overall in plant health. So we're not really sure what it does, but it certainly stops or reduces disease levels by roll. So I would recommend doing that. Again, another cultural practice that we're going to mention for reducing anthracnose is regular light top dressing. Again, if you want to know how to control anthracnose without chemicals, have a look at the Rutgers site because they've done a huge amount of work there. So regular light sand top dressing, again, is reducing anthracnose. So height of cut, rolling, regular light top dressing is going to reduce disease levels. And you can see it there, no sand, sand. What's happening there is, this is a nice photo of what's going on. This is not top dressed. So top dressing sand is actually helping to protect the crowns. And anthracnose, as we all know, is very much a stress-related disease. So you're reducing stress in the turf grass, reducing disease that way. Okay. So that's just looking at the growth environment and a few cultural practices that we all carry out on our grasses. And you can see by combining them all together, you're going to get some reduction. You're not going to fully control diseases, but it's going to help. And if you have if you do have a fungicide program in place, that's going to enhance it as well. So leaf wetness, know your enemy actually, know what it likes and try and influence those areas. Regular top dressing, oops, sorry about that. Regular top dressing, tweaking your height of cut, rolling, and any factors that you can influence to affect the microclimate that whatever disease you're working with doesn't like. So that's how you can help to reduce them. So what else can we do? I'm going to see what time it is. Oh yeah, plenty of time. So we're coming back to the pyramid of disease, right? And you're wondering what the time factor is here on this pyramid of disease. Oh, you're doing. Right. What's to say? You're not going to sit out in front anymore. Okay. No, what we're talking about here is, what am I talking about? Oh yeah. So the pathogen is there, environmental factors, the plant is there. The time factor is looking at how we can slow down the infection process, slow down the pathogen that's coming into our plant. But very importantly, how we can speed up turf grasses' responses and how it can respond and defend itself quicker. So that's the time factor we're looking at. As I said, they respond with some very complex defense processes. And the thing is, of course, the responses to infection are almost identical as responses to abiotic stresses as well. So you're looking at a whole range of things here. So don't panic. Again, this particular thing here, there's a half-day class on this section alone. So it took 4 hours. But basically, right, now this is not a turf grass plant, right, in case you're thinking, oh, what sort of grass have they got in Ireland? This is the plant being infected. So here's the leaf. The pathogen is coming into the plant. It gets in either via the stomata or it bursts through the outer cuticle. It wants to get in there. What happens, first of all, is something has to set off the alarm bells. So it could be a fragment of the fungus pathogen that's broken off, or it could be a piece of the cell wall of the plant. But the plant recognizes a problem, a elicitor, and that sets off the alarm bells. And the whole first response is to try to stop the infection from moving out from that infected area. And it involves things like what's called the hypersensitive response, production of reactive oxygen species. Who was talking about, chap talking about this morning about reactive oxygen species. It's important for plants to respond by producing these, but also the plant has to control them as well. So it's a bit like a nuclear reaction. If they get out of control, they can have a meltdown. But it produces all these chemicals here. I won't go on too much about it because we don't have 4 hours. But it tries to contain the infection because the cells surrounding the infection site then will die. Try to stop it from spreading. Same time, there's signaling compounds going out. These are a whole range of what's called phenolic compounds. That's the type of compound being produced. And it would lead to things like lignification. So the cell walls are being strengthened out here. And it's a bit like us. When we're getting infection, we produce antibodies. So plants, turf grasses will respond with these antimicrobial compounds, these phytoalexins, who would directly attack the infection. That's going on, we'll say here. Another thing that's going on is a salicylic acid is being produced and generated and accumulates in the uninfected areas. And that stimulates the what's called systemic acquired resistance. Anyone familiar with that, chat? Basically, infection starts here, tries to stop it, fights it off more here if it can, sends out signals to uninfected areas, and these uninfected areas then produce all these chemical compounds for defense. Now, they're not produced during normal growth because the plant doesn't have the resources. They're what's called secondary metabolites. So they're produced only during times of stress. And that leads to this long-term resistance. So the whole idea is, can we kickstart these defenses before infection? And yeah, we can. Actually, you're in Canada here now. Does anyone use Civitas? Yeah, we don't have it at home. But you apply Civitas, and that leads to an induced systemic resistance. So the plant is primed for defense. We don't have it, so we can't use it. But what we can look at, I just want to mention a few things. I won't mention phosphate. But at home, a lot of products now are containing things. Well, sorry, I won't mention Civitas. Maybe I will. I'm not sure what I'm going to show, actually. Well, silica, as I talked about a minute ago, chitin and salicylic acid are 3 compounds that are used a lot to try to stimulate these defenses. Oh yeah, I actually left Civitas eggs, I know I was coming here. So Civitas in Canada and the US, again you apply it and you get very good results apparently by stimulating defenses. That's the control there. What are we looking at here? Snow mold severity. That's the control level of disease. A whole range of fungicides there, which we don't have. But the Civitas with the harmonizer, very good at reducing disease. And that's just by stimulating these defenses we're talking about. Likewise with anthracnose, just by stimulating these defenses before infection, you're going to get a good reduction. And you can see the differences there. Anyway, so how does it work? Well, this is how it works. When you apply Civitas, this is not applied here. This is where it's applied. You can see it causes a problem with the stomata. Basically, it's stressing the plant, similar to what I was saying about rolling. Stressing the plant before infection, the plant is producing these compounds for defense. So that's how Civitas basically works. Now, we talked about silica and the nanosilica Aquaritin 19. Don't mix it up with silicones, right? Although, I'm thinking of looking into this. It looks fairly interesting. But silica, as I said earlier on, when you apply it, it can form this barrier along the cuticle, or along the cell walls, similar to what the plant does itself with lignification, to strengthen the cell walls. So it's slowing down the infection and giving the plant time to respond with these things. Also, some pathogenic fungi, it's been found that silica has a direct effect on their growth. So it can slow down their growth in the plant also. Now that's from Florida. I'm just going to show this. This is done down in Florida with grey leaf spot and prairie, and it's a warm season grass. But it's quite a high rate, this one is. So applying that, this is elemental silica. You can see, or silicon, some people call it, with, what's the disease? Oh yeah, grey leaf spot. You can see it reduced it. Chlorothalonil reduced it. Combinations again. This is where we're looking at different modes. That's a high rate. Now, maybe if you'd gone with a nanosilica, you could have gone out with less and the same result. Well, silica is an interesting one there, looking at controlling disease. What about chitin? Anyone familiar with chitin or chitinase? Anyone use that? What? No? Well, fungal cell walls are made up mostly of chitin. And by applying products with chitin in it, you're sort of tricking the plant into thinking it's been infected. So it acts as an elicitor. So you apply it, picked up by the plant, and it kickstarts these responses. That's the theory. Quite successful in agriculture. Salicylic acid, I mentioned, is a signaling compound. Again, there's quite a few products at home that include you're applying salicylic acid to generate this induced resistance. There's some work done in Penn State, I believe, where they applied a form of salicylic acid to a perennial ryegrass, and they got a good reduction in grey leaf spot. Again, just by applying this and stimulating defenses. Now, what I will say is things like chitin, salicylic acid, even silica, we need a lot more research specifically with turf grasses. So we need to work out the exact rates of these compounds and timings and long-term effects. This is where I normally say that one defense activator that has a lot of research behind it is phosphated, but I actually left that out since it's complicated here in Canada. So the plants need the resources. You need a balanced nutritional program so that the plants can call on these and produce these extra compounds for defense. And it's likewise with abiotic stress responses as well. But another thing I will say is that most of these, that's not my slide there, the phosphorus is not spelled correctly, but most of these elements and compounds can have a direct effect on disease levels. So, as I said, I had this talk with Michael Woods about just MLSN, and he's saying about you don't need to apply so much. So I say, well, you're not applying these as a nutrient source, basically, because you probably do have enough in your root zones. You're applying these because of the added benefits they can supply. So all of these here can have these extra benefits. And that's sort of the research aims we've been looking at over the last few years, looking at various programs which contain these here, different combinations, and how they affect plant health, how they stimulate defenses, how they suppress diseases as well. Yeah, that's just from Rutgers as well, where they looked at spoon-feeding nitrogen, crucial way to reduce anthracnose through the summer, apart from the culture. So if you're doing the cultural practices we talked about, you need to spoon-feed nitrogen. You can see where the regular inputs here reduced it, doesn't control it, but it's all coming together. Iron, who uses iron through the autumn winter here much? Commonly used at home, for generations in fact. Sulfate of iron has been found to reduce microdocium. You can see it here. This is done in Myerscough College in the UK. Untreated control, fungicide when they had it. But ferrous sulfate applied at 10 kgs every 5 weeks through the autumn winter. Good reduction just from fine iron. Again, let me point out with anything that we're looking at, just because it works doesn't mean you go to town on it. Don't lorry it out. Just use your common sense and do not over-apply anything, obviously. Now, we're all experienced with turf grasses, so we know not to overdo things, hopefully. So, sulfate of iron. Chelated liquid iron, again, that has had a direct effect on microdocium. This is again done in the STRI. So that's the control there on top, this light coloured one, the level of microdocium. Applying the chelated iron at the first signs of disease, they got a very good reduction, statistically better than the others. So a good reduction in just by applying a liquid iron on its own. We're going to talk about potassium with anthracnose. This is from Rutgers again. So soil levels, if you drop down below 35 ppm of potassium in the summer, you get a much higher level of anthracnose. So you need to maintain decent soil levels there of potassium. Calcium, hello, what's wrong with this? No, we're back again. Thank God. Oh, well, maybe not, says you. Well, calcium, yeah, it's a funny one. As we talked about earlier on, it can become locked up in the soil. In the plant, it can be very immobile, but as part of these defense processes, this very first hypersensitive response, it's important for what's called the ion flux. Now, you might think I'm making this up, do you? No? But the very first response requires an egression of hydrogen and potassium out of the cells and an ingression of calcium. So calcium has to be available within the plant. So it's important that that's there for this first line of defense. So what I'm trying to point out is all of these elements can have an effect on disease levels. Here's something we use a lot now in the last 5 years. Manganese and zinc. Very commonly used now through the autumn winter. Very, very popular. Not surprising, because manganese and zinc were the main components of these old fungicides like mancozeb. So guys go out maybe every 3 weeks, every 4 weeks from September right through. They're applying turf harders, liquid iron, some nitrogen, potassium, phosphate, manganese and zinc. And they're getting very good reductions in disease levels while maintaining good quality of turf as well. And another element I want to mention is copper. Again, a micronutrient. You probably don't need to apply it, but as a disease control, it's actually gone back even to ancient Greek times, where they mentioned, Homer mentioned copper control disease. Now, I don't mean Homer Simpson, by the way. The ancient Greek Homer mentioned copper control. And that went out of popularity in the 1920s, started to more of these synthetic fungicides to me. So all of these elements and compounds I've been mentioning have these added benefits of helping to reduce disease. You saw this a minute ago from Clint, where sulfur, potassium phosphate on their own controlled it. Combining them together along with rolling is very effective as well. That's just some of the places. That's the Royal Corridor. That's Croke Park in Dublin, the main stadium there, holds 80-something thousand. That's 2 miles. That's the Curragh Racecourse there. Just some nice shots there. Cricket. I don't know much about cricket. I don't really want to either. So it's an unusual looking surface. But what I want to show is some of the research now where we started combining all these elements I just mentioned, these micronutrients and compounds. And great, should go okay for time as well. So I want to show some of the research over the last few years I've done, looking at controlling disease, putting these elements together. This is the first one from 2018, and it's for anthracnose. 2018 is a very dry summer at home, actually, and with a lot of stress, both for greenkeepers and for anthracnose. So we had untreated control, we had a phosphate, but we had this nutritional program which had NPK, calcium, sulfur, copper, manganese, zinc, phosphate, salicylic acid, silica, and a surfactant. So that was the program we put together. This I won't mention any product names, but that was going out. We had Banner Max, which has since been banned over there. We can't get that anymore. So that went out from July to October 2018. Every 14 days, we looked at disease levels and we looked at how it affected turf quality. So I'm just giving the thumbs up to the camera here. Can't resist it. And this is what we found basically, anthracnose levels. This is July to September, the mean levels. So control there, yeah, about 20% worked out at. The phosphate on its own got a good reduction, 67% of the control. The Banner Max, 2.35, very, so almost totally controlled the anthracnose. But if you notice, statistically, this nutritional program was as good as the fungicide at controlled anthracnose. But apart from that, I don't think I have it here, but apart from controlling anthracnose just as well as the fungicide, the turf quality was better as well. So that was a good result there. What was going on there was the phosphate, from what we published, phosphate, when you apply it, will actually stimulate those defense processes. We measure the defense processes in turfgrass, and phosphate stimulates these compounds prior to infection. So phosphate was stimulating defenses. This 2900 product, apart from supplying spoon-feeding nitrogen, which was important as we saw from Rutgers, it also had all these elements in also. We had another one which again ensured we had enough NP and K for that time of year. Now actually I'll point out that all the plots received a granular prior to the start, so the control wasn't stressed out or anything. So that was, sufficient amount of nutrients there. We had a surfactant going in. Again, this was reducing stress. It's ensuring there's a more consistent level of moisture. And it was also had an acid in it, which was talked about earlier on. It was helping to solubilize and release calcium, we think, because it's a very calcareous soil these trials were on. And a biostimulant that was going out in the program, which included salicylic acid. So it had all these elements I just mentioned, and they worked together, and you can see very good reduction there compared to untreated. So the next one I want to look at, same year, 2018 into 2019, looking at microdocium. This is the Royal Corridor trial site here. I was still there at the time. Again, it's similar to what we looked at for the anthracnose, untreated. We had a phosphate. Nutritional program, similar enough, but less nitrogen going out because it was the autumn, winter. We didn't need much. And a chelated iron, which we added in towards the end of the trial also. and in strata, which was banned since. Not my fault, but anything I seemed to use was banned. Anyway, then went out every 14 days, and this is the results from that. So it's 2 sections here. The first section from October to January didn't have the chelated iron in it. Control levels here. Fungicide, yeah, good control. The phosphate on its own, very good. Almost 60% reduction, which was good. The nutritional program we put together, yeah, further reduction. You will note same letters here, so statistically no difference actually. So when we added the chelated iron for the last 3 months, we got a further reduction again, up to almost 72% reduction, this nutritional program. So that had the NPK, it was calcium, sulfur, copper, manganese, zinc, phosphate, salicylic acid, and all them. And as well as controlling the disease, it was also enhancing the quality also. We had much better quality there, as you can see from some of the photos. Again, phosphate suppressing by enhancing defenses, nutritional program, enough nutrition so that the plant, the turf, had resources to help defend itself. All them going in there, salicylic acid was stimulating the systemic acquired resistance. And the chelated iron, when we added it in, again, further reduced. So, you sell all this stuff, Dave, you do?
Yep.
That's a good. Give Dave a call. Okay, I think this is the last trial I want to show from, this was done during COVID, and we had nothing else to do. We couldn't go anywhere. 2020, 2021, we had looked at all this stuff here. 2 sites this went out on. My own site at home, which was Poa annua on a USGA sand root zone, and up in Dublin at the Spa Well Centre, which was the traditional push-up Poa annua green. 2 sites. That's all the stuff that went out. No names on it, but basically it was 6 treatment programs. Went out at a 14-day or a 28-day rate. So basically 12 plus untreated control. So a lot of stuff going out. We looked at, I'm only going to show turf quality and disease levels here. So obviously microdosing was the main. I'm only going to show the results from my plots. This is Poa annua on USGA soil. Control. Now all of those had an effect, reducing disease. Now we're not going to go through them all. Here's the thing as well. These work very well. Now they may have worked better in a different situation than these ones. But as I said earlier, we're looking at results from this particular trial under those circumstances. So those there worked very well. And what they were was a phosphate only with a copper-based pigment, and a phosphate with a manganese, zinc, copper, iron micropack together. So they worked very well. 2 different rates, 14-day, 28-day, all in metrics, sorry. What they did, I haven't got any letters on these, but control here, very good reductions there, just from the nutritional inputs. Up to 76% reduction. And that's the phosphate, manganese, zinc, copper, and iron. But the phosphate and the copper-based pigment had a very good effect also. And it was consistent. This is the October, right through to March, starting off here. So a consistent reduction of disease right through the period. Peaked around, I think it's 28th of December that year. So really good reductions there, right through. And this is the effect on turf grass quality. So starting off, this one here actually was slightly less. But as you can see, as the treatments kicked in, the quality was sustained and better. So better reduction of disease, a good reduction of disease, and better turf grass quality. And the clue, what's next? Oh, it's a couple of pictures from those again. I think you can see the differences there, all right? That's the phosphate of pigment in it. Taken the same day, of course, in the same place. Quite a nice difference there. Again, the pigment was given a good colour. So how was the pigment helping, do you think? Well, did you ask that question? No. Pigment, I think, was helping. First of all, the darker colour through that period was helping it get more heat, and attain more heat and more metabolic processes. But also, it's a copper-based pigment. So, because I said copper has been used as a fungicide for centuries, so that's what was helping there, I think. Again, that's the manganese, zinc, copper, iron combination. Very nice colour, good disease control. Same there. And this is the take-home points for this section. What do you mean? There's another section going over it. So the take-home points about controlling disease without or reduced fungicides is look at all the environmental conditions that your particular disease likes and see what you can do to reduce them. Things like dew removal. I put the timely use of aeration operations in because at home there's a lot of pressure from committees and members to carry out heavy aeration and heavy top dressing way past the season into October, November. So that's, going out with heavy top dressing then is creating a microclimate for disease. It's totally different from light top dressing through the year. We're not smothering the grass. So heavy top dressing at particular times can be detrimental. Tweak your height of cut right through the year if you can. The higher cut you can get away with, the better. The plant's going to be healthier, better, like us. If we're healthier, we're better able to withstand infection or disease. Rolling definitely reduces disease, so get that into your program. Again, know your enemy and see what it likes and what you can do to reduce it. You need a balanced nutritional program because a lot of these defenses to abiotic and biotic stress, there's no free lunches. The plant needs to be able to pull onto the resources to produce these compounds. Use defense activators that we mentioned. They all will work. And so hopefully if you incorporate even some of these processes in, you're going to enhance your quality and you're going to help reduce disease. Hold on. Yeah. And if you have fungicides, what we've been talking about there, what I've been talking about, is going to enhance your fungicide programs. So you get better results, better efficacy from your fungicides if you're doing all of that as well. And I don't know what that is. Oh yeah, sorry. So that particular section is over. Any questions on that? Well, I'm pain in my arm. Someone hold this microphone for me, will you? Anyway, I'm going to talk now, as I said, an independent researcher. And for the past 5 years, some of the stuff I've been doing, looking at surfactants, in collaboration with a couple of different companies, different surfactants. Anyone call them wetters? No. Oh, we do it in the UK and Ireland. I was doing the conference for the young greenkeepers in England last year, and Frank Rossi was here with me. Anyone know Frank from? Yeah. And he looked at that and he started laughing because apparently wetters means something totally different in the US. So I'm going to talk about surfactants. Who uses surfactants? Most everyone, I'd say, yeah? Okay. The first surfactant I ever used was washing up liquid back in the 1980s, where I was sent down to the local shop to empty the shelf because we had a local dry spot. So I'm going to show some work we've done. That's me with me pogo out there. I want to show some work we did over the last, this is 4 years. Surfactant work in 2020 to 2023 last year. This is 2020, and as you can see, 7 different things going, well, if you count the control, 7 different surfactants going out here. 2020, whatever that is, 2022, we had 10 different ones going out. Last year, 2 different trials run with 14, 15 different surfactants, about 11 or 12 here. So a lot of stuff going out over the past 4 years. We're going to start with 2020. And this is the rainfall where we did the trial. Now, these here are the average rainfalls in Ireland for that particular site. And when we say average, in Ireland, it means wet, probably the same as here. So that's the average there. As you can see, we started the trial in June, and you can see the amount of rainfall we had through the summer. So it pretty much rained every day. And I was thinking, oh, this is a waste of time, isn't it? Actually, it was the same last year. That's the rainfall for last year as well. So that was okay, June. July was horrendously wet. We actually had almost 3 times the 30-year average rainfall. So August was very wet, September was very wet. So 2 wet summers I'm going to show first, where we did these trials with surfactants. You might think, well, what's the point in using surfactants when it's so wet? So we'll see anyway. So this was 2020, the wet summer. We had 10, I think, gone out, or no, sorry, 7 treatments, if you count the control. So the average volumetric water here over that full trial, well, there's no difference. So the control was the same as all the surfactants, pretty much because it rained every day. So I think that this is a waste of time. No difference in volumetric water, no drought stress, obviously no wilt. But when we ran the data and through the stats, we found there was a significant effect on turf grass quality. So you can see it here. This is the mean turf grass quality for that period. Sorry, hold on now. That's the control. So all the ones that received surfactants, even through the wet period, had much higher quality. And you can see it there, starting off, they're all much the same. So improvement in quality during the wet summer. Again, that's Royal Dublin, where we did it last year. Another wet summer. And you saw how wet it was in July and August. Starting off, the quality was the same, but as they kicked in, all the surfactants enhanced quality. This is the second trial we did last year. Again, enhancement of quality. Every one of the surfactants we tried, some of them were experimental compounds, some were products on the market, and some were combined together. So they all improved compared to the dotted control. And so what's going on that we had to figure out, and we got it. It was the same now in 2019, Dr. Mike Fidanza, you know Mike from Penn State. He used the surfactants I used in 2020. And they had a wet summer in Pennsylvania as well in 2019. And he also got this enhancement of quality. So what was going on there, we had to try and figure out. Just move on to this because it's better. So work done by these guys here, not with turfgrass, but with surfactants in plant health. They found that applying surfactants increases the wettability of the rhizosphere. This is the interaction between the plant and the soil. So the more consistent level of moisture available there, and they found increased microbial activities and biological interactions just from using surfactants, enhanced enzymatic activity, and very importantly is all of these elements here, right across, that's how much the uptake was increased compared to non-surfactant treated. So basically what's happened is it's maintaining a better level of moisture. The elements that are there anyway, without applying any, were taken up better. I think you've probably seen that if you're using the TDR or the POGO. You get the higher moisture levels, you get the higher EC readings. So that's showing that the salts, in this case nutritional salts, are more available. So we're getting all this going on just from using surfactants during wet weather. We did a trial then right through last winter. I haven't got it here. Again, it was a wet winter in Ireland. I'll see you there, said Jim. But we did this trial again using surfactants. Same thing, enhanced quality. We also looked at how it affected surface firmness as well. So as you would expect, it was actually improving the playing quality as well. So it's important, I thought, to show that, because I would recommend now, I said I'm not here to sell you anything, but I would recommend using surfactants year round in this climate. Obviously not over in eastern Canada, but where it's frozen. But in a climate similar to us at home, I would definitely recommend using surfactants right through. That research we did over the last 4 or 5 years has actually gone in to be published in the International Turfgrass journal. So it's being prepared at the moment. So, and from a plant health point of view, or disease point of view, you're getting this healthier plant, again, without banging on too much. The healthier plant is more able to withstand disease. Now I'm going to go now to a different kettle of fish altogether. They were 2 wet summers. (2022) was a slightly different scenario for us at home. It was dry. Now June, the first part of June was normal, it was wet. But from mid-June right through to the end of August, it was dry and hot. Okay, dry and hot. I don't get to say that much in Ireland, but you can see there's the temperatures. Now, that's very hot, right, for us. What are you laughing at? If we get to 20 degrees in Ireland, we just shut up shop and go to the beach. That's it, right? You have to. But that was extremely hot there, that period. 20, I mean, come on, they nearly killed us. Seriously. But it was also very wet. So we got some really good drought stress data from using surfactants. This is the thing that went out. 10 different treatments went out, different surfactants went out every 28 days. And so this is the rainfall on those trial sites. That's where the heat wave kicked in. So 2 months of very dry weather. This is the water, the moisture in the untreated control plots. Pretty much followed the level of precipitation or rainfall that we did get, as you can see. I'm only going to show, I want to get rid of them. I want to show one because it's much clearer this way. So, rainfall, level of moisture in the untreated control. But you can see where the surfactant was and 2020. So we were leveling the curve, as you can say. It's really interesting, I thought, and I wasn't really sure how they did it, but this wet period here, it was maintaining a slightly drier turf. And during the dry period, it was retaining moisture more. So a much flatter level of moisture, more consistent right through. That's to do with the structure of the surfactants. They have these hydrophobic and hydrophilic compounds, which some of them reject water and keeps it running through, so others hold on to it. So basically it's the ratio and combination of these different compounds affects how a surfactant works. So a lot of them would be different. This particular one, as you can see, does do the job. So I thought that was very interesting there. We actually had wilt and drought stress, which we don't often get. You can see all the surfactants help there. Tell you what, I'm getting really good on timing here. How good is that? But yeah, drought stress. So as you would expect, all the surfactants we used, this is just during the July period when we had a really good drought, they all reduced drought stress compared to the control. Now, Dave is going to give an award or a prize to anyone who can pick out the plot that didn't receive surfactants. Yeah? No?
Absolutely.
But this was, as you can see, these were treated with surfactants side by side, totally different. So this is just showing the benefits of using them actually, which you're probably well aware of anyway. But I just thought I'd show them because we don't get that much drought at home. But this one here is particularly good. Again, just side by side, the value of surfactants there. So just to sort of go over that, what we found from, again, I mostly deal with disease and plant responses, so these surfactants were different kettle of fish, but it's all about applying the treatments, gathering the data, assessing it and analysing it and producing it. And this is what we did find from using those surfactants. They will improve soil moisture consistency right through the year. You get a reduction in drought stress. Well, that's fairly obvious. You do get a surfactant effect on surface firmness. Again, we found that, especially with the more Kensington type surfactant, a firmer playing surface. This is the big thing, I thought. Even during wet periods, the quality and health, now I didn't show it, but the NDVI levels were much higher from surfactant use also. So even during wet periods, you're improving that turf grass quality and health. And as I say, from my herpetologist hat on, a healthy plant is better able not only to withstand infection, but ongoing abiotic stresses as well. And you're getting this increase in nutrient availability, as being shown in that published paper. Oh my God. That's not bad. So that's the end of the 3 talks I was going to do. There's my contact details. You can get me there. That's my research associates. Now, I don't think we were associating or investigating turfgrass that night. So, hopefully you enjoyed or took some interest in what we were talking about today. And here's the camera out. So, hold on. I'll take a selfie. Okay.